Last time we started taking a look in this section at the Pythagorean theorem, distance formula equation of a circle, and we really just did the Pythagorean theorem, but I made a comment last time that these really are all three the same thing, right? So we'll get to that later in the lesson today, but first we're going to take a look at some special right triangles. All right, so one special right triangle is a 45, 45, 90 right triangle. So when we have this, we have a 90-degree angle and two 45-degree angles. And obviously that creates an isosceles triangle. And visually, you can think about it as being really like half a square. I mean, that's one way to visualize this particular argument. And in general, when we have an isosceles triangle with legs of length a, then the hypotenuse has length a square root 2. And I thought I would show you at least this one as to why that's true, because it's pretty clean and straightforward. On this one, if I had, oh, I need a different color, just a sec. Go with that. If I have a side length here of A, and this is the side length of A, and I'm trying to find the length C, then I can use the Pythagorean theorem, right? And it would say A squared plus A squared equals C squared. That's what it would say. And we could combine the A squared and the A squared, and I hesitate to ask this because I don't want you guys to say the wrong thing, but does anybody know what that should be when we add those together? It's not to the fourth power.
Is it 2A squared?
It'd be 2A squared. Remember, the only time we add the exponents is if we were multiplying the bases together. So this would just be 2A squared. And then if I'm trying to solve for C, what would I do? It would square root. So I get C alone. I don't have to worry about a plus or minus because I'm talking about lengths of sides, so they're always going to be positive. The square root of 2 and the square root of A squared, those can be separated because the 2 and the A are multiplied. If there were addition underneath that radical, you couldn't do that, but because they're multiplied, you can. And what is the square root of A squared? A. So this ends up giving you A and then radical 2, and that's what you're seeing happen right here, is the A and the radical 2. So I don't know what you remember from when you learned about these special right triangles before, but I remember setting things up in columns. That's what my teacher taught us. And so we had, you know, the side length that this was the 45-degree side, and this was the 45-degree side, and this was the 90-degree side, and the ratio was 1, 1, radical 2. And so just moving between those sides either meant that you multiplied or divided by a radical 2, depending on where you started. And so we see that happen with these right triangles that are isosceles, 45, 45, 90. There's one other type, though, too. What was that?
Were you finding the square root of 2? The square root of 2? Like, there's no square root of 2 on that.
On my picture?
Yeah, where is that coming from?
It's not on there yet because I didn't write it, but it's right here.
Oh, okay.
It's the length
because
C.
Of the, okay, that makes sense. Okay.
Yeah, it's the length of the hypotenuse C.
Okay.
Okay. All right, so this is one of the special triangles. And the other special triangle, and I'm sure if given enough time you would recall, is the 30, 60, 90 triangle. So in a 30, 60, 90 triangle, a right triangle, is half of an equilateral triangle. So if we took an equilateral triangle, okay, so the 2, 2, 2, you see how the side lengths are the same, and you cut one of those angles in half, then it was 60 degrees and now it's 30 degrees, right, when you cut it in half, which automatically makes it a right triangle when you drop that altitude down, that side length down, because you have to have 180 degrees in each side of that triangle itself. So in each half you create two triangles. So you end up with a 30, 60, 90 triangle, so one half of this equilateral triangle. And there is a special relationship there as well. So the relationship in a 30, 60, 90 triangle is that the length of the hypotenuse is twice the length of the shorter leg. Okay, so the shorter leg is the one opposite the 30-degree angle. And the leg opposite the 60-degree angle is square root of 3 times the length of the shorter leg. So the first thing to recognize is that the 1/2 part's really straightforward. So if I take this triangle and I cut the side CB in half, obviously that side is half of what it was before, right? If I'm only looking at, say, half of this triangle like this, right? So whatever this side length is, say A, then this would be half of it. Agreed? Because I cut it in half. And I could find the third side using the Pythagorean theorem just like I did before. So just for fun, we'll use the side lengths that they have here because it's a little easier to work with numbers than letters, and I know that. So you've got a 2 along the hypotenuse right now, and we will have a 1 right here, correct? So there's the 2 here, here's the 1. And we're going to find the length of that third side, the one that's not marked. It's in the middle, the altitude of the triangle now. So if we do that, we would have, and we'll need to give it a name. What do you want to name it? B? No. How about X? We'll just call X the length right here. All right, so we have the side, 1 squared, plus the side we don't know, X squared. And it equals the hypotenuse, which is 2 squared. And if we add these together, or square them first, and then add them together, so I have 1 plus x squared equals 4. What would I do next? Subtract the 1, so I have x squared equals 3 then. And if I take the square root, you can see where the radical 3 comes from. And again, one way to do this or think about this when you're encountering problems is that you've got a 30, 60, 90 relationship, and the relationship here is 1 square root of 3, 2. So if you can figure out, or if you're given the side length across from the 30, then everything else is multiplication. So that value times square root of 3 or that value times 2 to get the other sides. And if you're going backwards, you do division to get to the side length that's across from the 30. Okay, so we're going to use some of that information in order to find the next problems, the answer to the next problem. This question actually asks us to find the area of the given triangle. And you guys know the area formula. That's back in section 4.2. So what is the area of a triangle formula? Right, 1/2 the base times the height. Now the question here in this triangle, though, is what is the base and what is the height? So one of them is marked, and you know it. Which one? The base. What is the base?
S.
S. So the part that's along the bottom, that's got the, and honestly, they're all the same on this one because it's an equilateral triangle. But this one here that's along the bottom is the nicest one to let be the base because the perpendicular here then could be the height, right? Everybody with me on that? Okay, so we know that the base is S. So now we have 1/2 S. And we have to figure out the height. Well, the height has to come from that same relationship that we just saw in the last slide because this is a 30, 60, 90 triangle if we look at half of it. Agreed?
Half S times square root 3.
Okay, yeah, so right now the half of, there, somebody said, is it half of S? And it's not quite half of S because that would be this bottom part, right? That does not look like a 2. Let me try that again. That's better. So the bottom here is the 1/2 S part, right? It's the opposite the 30 degrees. So here's my 30-degree angle right here. It is the 1/2 S, but we want the height, and so the height is the piece that we would have if we were setting up this relationship. We'd have that, whoops, 30, 60, 90, and we're given actually the one that's opposite the 90, which is S, and we know that the 30 degree is half of that. And the way that we get then to the 60 degree, Brendan, you were the one who I heard say it most clearly, is that you would multiply, right? By what? By square root of 3. So if you can figure out what the side opposite the 30 is, then you would multiply to get the side opposite the 60. So it would be 1/2 square root of 3S. A lot going on that side of my
Is
screen.
the S under the radical too?
It's not. That's a good question. I'm glad you asked. Please make sure that it looks that way very clearly on however you're choosing to write it. If I have to guess, I'm not going to be very happy because I'm not going to know for sure if I'm counting you right or wrong, okay? So I've drawn mine so that it doesn't look like it is. If you're really unclear or want to make very sure, you can put the S in front of the radical, which is probably an even better choice so that you don't have to be so careful with it. Okay, so that's my height. My height is 1/2 S radical 3. Before I move on, we need to make sure, is everybody okay with that? Any questions on that?
Is the radical 3 coming from the stuff that we just talked about earlier?
Yes, the
Okay.
radical 3 comes from
I
this
just wanna make sure.
relationship right here. Yes. Yeah, so radical 3 comes from 30, 60, 90s, and the radical 2 comes into play with, we have 45, 45, 90s. Okay, so we're almost ready to find the area, or we're almost to have found the area. So if I have the 1/2, these are all multiplied, so I can switch up the order of everything, right? That's called the commutative property of multiplication. So I can actually multiply the 1/2 and the 1/2 to give me a 1/4. If I want to be careful with the s, I can still list it next, and it would be s squared, because there's s times s. And then I would have a radical 3. The other way you could see this written, or if you would like to write it that way, is you could write it as radical 3 over 4, like this, and then s squared at the back like that, which would be very clearly also not having the radical underneath, or the s underneath the radical. So either of those versions would be our area for our problem. All right. So our directions talked about Pythagorean theorem, and we kind of threw in this little bit about special triangles, but I showed you where they came from in terms of Pythagorean theorem, so that's what it's related to. The next component in here is called the distance formula. So the distance formula is really the Pythagorean theorem in disguise, like incognito. So go ahead and write down the formula for it, and then I'm going to show you why it really is just the Pythagorean theorem. The distance between the points A, which is x1, x1, y1, and B, which is x2, y2, is given by AB equals the square root of x1 minus x2 squared plus y1 minus y2 squared. A few cool features here. Notice, it does not matter whether you do x1 minus y1 or y1 minus x1. I didn't say that right at all. Let me start over. x1 minus x2 or x2 minus x1. Why wouldn't it matter which order you did the subtraction in here? Because you're going to square it first, actually. You're going to square it. And what happens when we square values? They all become positive, right? So if you think about taking numbers, like if you did 5 minus 3 and you did 3 minus 5, they obviously have different answers, correct? But like they're almost the same. How different are they?
One's a positive number, one's a negative number.
Yeah, one's positive, the other's negative, but the value after the sign is the same, correct? So when you square them and there's no more sign difference, will they be the same? Yeah. If I take these values and I square each of them, I get the same thing because I lose the positive or the negative value that I originally had. Or you could say they all become positive. Okay? So that's one thing I wanted to point out to you. But I would like to show you why this really is just the Pythagorean theorem. So if you have a coordinate grid, and you have 2 points on there, and it doesn't even matter where they are. So I'm going to sort of put them in between weird places so that you don't go counting things on me. Because my goal is not for you to count here. I'm not trying to give an exact example, okay? And you connect these with a line segment. That's what you would be finding the distance of if you use the distance formula. Agreed? The distance between 2 points is known as the shortest distance. We always talk about it being, you know, as the crow flies, the shortest distance. So this doesn't work very well when we really think about like driving places and maps and things like that, right? The distance from here to my home is not a straight line. So if I try to do a straight line distance formula, it doesn't really work very well. But it does when we're talking about a coordinate grid. This is the kind of distance we're referring to here. But notice what would happen if I drop down a horizontal or a vertical line down and then a horizontal line across. What in the world is that? It is a right triangle. And it is a right triangle where this distance right here is the change in the y values. It's y1 minus y2. And this distance right here is the change in the x values. It's x1 minus x2. So if you subtract the y values and square them, and you subtract the x values and you square them, and you add them together, you get the hypotenuse squared, because that's what the Pythagorean theorem tells you. In other words, if you were to take this distance formula and you were to square both sides, you would have c squared over here, a squared here, and b squared here. Cool, right? It's a different way of looking at it, but it's a distance formula. All right, so we're going to find the distance, and we're going to find it both ways just because I want to show you that it really works. We'll use the distance formula as a formula first. So we'll call this AB. They didn't really tell us our points were A and B, but that's a fine. Okay? And we're going to take the square root, and what we want to do is we want to, if you will, identify, just so that we can have some values that we're all putting in the same thing, the same place perhaps. This will be x1, y1, and this will be x2, y2. Okay? So what will I put in here first? What was it? 2? The way I wrote it, did I do x1 minus? Yeah, 2. I did. Okay, 2, and then minus what, Morgan?
6.
2 minus 6, those are my difference in my x values, plus, somebody else help me out for the other half. 5 minus 8, thank you, Jessica. So 5 minus 8, and I'll square those. So what is 2 minus 6? It's negative 4. We'll square it in a second. And then what is 5 minus 8? Negative 3, and we'll square that. All right, so what is negative 4 squared? 16. 3 squared? 9, or negative 3 squared. And I add these together, and of course get 25. And what's the square root of 25? 5. And are we always going to get a whole number here? No, we're not. So if you don't get a whole number, let's just go with 2 decimal places unless it says something different, okay? If there's units on the problem, we're going to put the units down here as well. This is a length, so this will be linear units. Okay? Now let's think in terms of drawing a picture. I think I can draw this big enough because these numbers aren't too large, or draw this small enough. So this is the point 2, 5. So here's 2, 5. So it's like right here. And then I have 6, 8. Right here. Okay? And what I'm trying to find is the distance between them, of course. So again, if you think about it from the perspective of a triangle, you can draw these in here. The length along the bottom is how far? It is, I'm meaning the number though, Lauren, not like the general expression, but what is the length right there? The length's not 16, length is 4. When we square it, we're going to get 16 in a minute. But the length's 4, right? Because it goes from x equal 2 to x equals 6. Is everybody good with the length being 4? What's the height of this triangle?
3.
It's 3. And again, that's because we're going from 5 to 8. And we've got a Pythagorean theorem, which says that 3 squared plus 4 squared has to equal c squared. 3 squared is 9, 4 squared is 16. You take the square root, you get 5. Okay? Very good. All right, here's a more fun example, application, if you will, of not just like here's the distance formula. We're going to find the perimeter of the triangle. Okay, so what is perimeter?
The distance around.
The distance around. So how in the world would we go about finding the perimeter of a triangle?
Adding the sides.
Yeah, we need to find 3 side lengths because we have a triangle. There's 3 sides, right? So they've given us labels on this one, A, B, and C. So one of my sides that I'm going to have to find is AB. What's another side I'm going to have to find?
BC.
Good. Oh, I don't mean line above them. BC. And what else? CA. So I'm going to find these 3 lengths, and then we're going to do what Catherine suggested, which was add them together when we're done. All right, so if we do A and B, and we'll go with the distance formula because I don't want to draw a picture this time, okay? But what we really want to know is how far away are 0 and negative 4. So how far away are 0 and negative 4? They're 4 away from each other, so this is 4 squared. How far away are 0 and 3? Those are 3, so that's 3 squared here. That's just the same one I just did, right? So this is 16 plus 9, which is 25, which gives us 5. And we're 1/3 of the way done. Well, kind of 1/4 actually. All right, BC now. All right, so now we are going between -4 and -5. How far apart are those numbers? They're only 1 apart, so this is 1 squared. And then -3 and 0, and how far away are those 2 numbers? 3. This is all about lengths and distances, correct? So I don't really care about the signs because I'm squaring everything anyway. So what will this give me? The square root of 1 plus 9, careful, which would be square root of 10, which we have to leave. If we want to approximate it, or if we're working with something that has units, like a context kind of problem where there's, links that you're actually reporting back to a specific person to approximate with, we could do 2 decimals, but we aren't working with that here, so really that's fine. It's okay just like that is. CA, that's our next one. Let's go with that. Okay, let me erase a little bit. Whoops, that was not an eraser. That one is. All right, so we're going from C to A. So now I have the point 0 here and the point -5, the x values. How far apart are those? Those are 5 apart. And then I've got 0 and 0. And how far apart are those?
0.
Well, that's just 0. That's not very exciting, is it? So I actually have the square root of 25, which is 5. So what I need to do if I wanted to find the perimeter? Add up. We have 5, we have square root of 10, and we have 5. What will that be if I simplify that?
10 square root of 10.
Close. It's 10 plus the square root of 10.
Oh.
Without the plus, it would mean multiplication, and we don't really have multiplication here. We have addition. So 10 plus the square root of 10 is our perimeter for our triangle. Interestingly enough, looking at this, you should be able to tell me that there is a specific type of triangle here. It is a 45, 45, 90. How do you know, Sally?
Because it's 2 5s. They're both, the 5 and 5 are the same. The lengths are the same.
So what's another name for that kind of
It's
triangle?
an isosceles.
Yeah, this is an isosceles triangle because there's 2 sides that are the same. And because it's isosceles, it also makes it a 45, 45, 90 triangle because we know it's a right triangle. If it were a right triangle. Actually, do we know it's a right triangle?
It doesn't specify.
It doesn't specify it, so we don't necessarily know that it's a 45, 45, 90. If one of those sides is, and it is because the square root of 10 will work out that way, I think. But yeah, it does end up being so, I think. Maybe not. But anyway, it's isosceles is what I was going for, so it's isosceles. All right. Last piece in this section is equation of a circle, and I mentioned again last time and today already that this is just another version of Pythagorean theorem. So the equation of the circle says, suppose that, this one we're starting with it centered at the origin, just because it's simpler. Suppose that we have a point xy on the circle, and the origin is 0, 0, and it has a radius of r. Then the general equation of the circle is x squared plus y squared equals r squared. And does that not look to you like the equation of the Pythagorean theorem? It should. What's the only difference?
It's an R.
There's an r in it and an x and a y instead of a, b, and a c, right? It's just different letters is what it looks like. And again, you can take a look at the picture on the right-hand side, and it's justifying for you why that's happening. So if you take a look at this picture, you see that the distance here, the equation of a circle, is supposed to be the points that are all the same radius away from the center. Well, these are all the same, and these can all be created with a right triangle back to the x-axis or the y-axis, depending on which one you're looking at. And you have the distance x, the distance y, and you square each of those as legs of the triangle, and then it's the radius squared would be the hypotenuse of your triangle. Now it gets a little bit more complicated when the center is at a different location. So if you have any general center of the circle like HK, then you end up with x minus h squared plus y minus k squared equals r squared. And all it's doing is it actually has to subtract off where your h and your k, the center of your circle, are. That is how far away they are from the center, the origin as well. So we're going to do 2 very basic kinds of questions with centers of or with equations of circles. The first one we're going to do is we're going to take a look at being given the information about the center and the radius, creating an equation. So I'm going to let you do that one. And then after you've done that one, the second one, number 6, is going to find the center and radius of the circle given the equation. So it's going the other direction. So do your best to do these 2. Check with a neighbor, and then we're going to reconvene and make sure everybody has the right ideas written down. Do be careful. One comment. Notice here I should have made this mention. H and K are positive, correct? I mean, like there's nothing in front of them. It's just H and K. But when you see them in the equation, it's the subtraction sign. And of course, it's happening just like the distance formula. You're subtracting because it's the distance away, how far something is away. So in some sense, it kind of looks like the signs are opposite of what they were before, right? It was an H and a K, and it looks like I've got negative H and negative K because I'm subtracting. All right, give it a try on 6 and 7, or 5 and 6. Well, they're 5 and 6 on your paper, and they're 6 and 7 in my notes. Isn't that interesting? Should be 6 and 7. What'd you guys get on the first one?
Yeah, x plus 3 squared plus y minus 2 squared equals square root of 5 squared.
Okay, so can you just describe real quickly, Brendan, how did you get plus 3 on that one? You're right.
Well, the formula was x minus the value of x given, so x minus negative 3 squared plus y minus the y value given, so y minus 2 squared.
Okay, so he's starting with the formula, Morgan.
Yeah, what formula though? 'Cause I thought it was x squared plus y squared equals r squared.
Okay, it is when you have the center at the origin, but this one does not have a center at the origin. So we have an adjustment for that, yeah. Okay, so when we take x and we subtract a negative 3, we end up getting plus 3, right? So it actually looks again like this, the value changed. It was negative, now it's positive. The y value wasn't positive, now it's negative, and that's kind of what it looks like here because we're subtracting it. So we have y minus 2 squared, and then what is 5 square root of 5 squared? 5. So we could actually rewrite this at the end with a 5 over here, agreed? For cleanliness, simplify it. Okay, that's good. On the second one, we are given the equation, and we're supposed to identify the center and the radius. So what is the center of this one? Should be an ordered pair. Okay, so it's negative 3 because it's supposed to be the opposite of this value. And then why is it 0, Lexi?
Because it just says y squared, so it's not subtracting or adding anything.
Yeah, there's nothing grouped with y, if you will. So the only thing it can be is the 0, because y minus 0 would be simply the y squared. How about the radius? Someone else? It's 4. So why 4?
Because the square root of 16.
Yeah, common mistake. And I actually expected somebody to tell me it was 16. I didn't think about the 8, but that's another common mistake. So we want the square root of whatever value we have, and the square root of 16 would actually be 4. So this is what I have for my center and my radius. Any questions on that? Morgan, how can I help?
I'm just really lost.
Okay, we're
How did
taking
you-
the formula x minus h,
Right, I got that much, but I don't understand how you got, where did you get the 0 from?
because
Y
the,
squared? Okay,
yeah, if we're identifying these two pieces together, the only thing that k could be is 0.
okay.
And then on the other side, it's supposed to be r squared.
So it would be 16 squared.
Well, it would be the square root of 16.
Okay. Why is it the square root and not?
Because this says that r squared here equals 16. And if we
Oh,
were
and then
solving
you
for it,
take- okay. Okay,
right,
okay.
we'd get a 4. Okay,